This is my assembly traffic light, and what it does is it starts with an advanced green, which blinks 4 times over 8 seconds, and then it goes to a solid green before going to yellow, and then red for 8 seconds. Then it will repeat all over again. Assembly language is a form of code that works down to the basics of machine level operations. Being able to work at one byte at a time allows for less wasted clock cycles, but at the cost of complexity. For example, here is a comparison between the C++ delay 1 second versus an assembly delay 1 second. Now the process of code will be explained. Register 16 is used mainly throughout the code, in which the value of this byte is constantly shifted out to port D, and as the byte value changes, different pins go high and low. Since the traffic light is placed on pins 2, 3, 4, and ground, to flash on the green light, the byte 0x04 must be shifted out to port D. To begin, the value 0x04, labeled as data, is placed into register 17, and 8, labeled as num, is placed into register 21. LDI is the name of the instruction used to do this, which immediately loads a constant k, in this case num, to any register, and in this case it's register 21. Next, the loop opens up and data is also loaded into register 16. When the advanced green process begins, register 16 is XORed with register 17. Initially, this will make the value of register 16 go to 0. Then, register 16 is outputted to port D, the delay 1s function is called, and then a 1 is decremented from register 21. Then, a branch if not equal instruction is done. Essentially, it checks if the previous byte of data is equal to 0 by checking the 0 flag. Since register 21 will be holding 7 in this iteration, the code will branch to advanced green because the byte was not equal to 0. Essentially, this will repeat 8 times over, and every other time, when R16 is XORed with R17, the green LED will go blinking on and off. Once this is over, to then shift out the yellow light, a bit shift instruction LSL is done to register 16, which is then outputted to port D. Then the delay function is called a few times, and lastly, R16 is bit shifted once more, and the red LED goes on for 8 seconds by using the decrement and BRNE as done for advanced green.